What is impulse? Well, when we think about the word impulse, it is a term that quantifies the overall effect of a force acting over time. And so we can actually put that together as an equation. Impulse is signified as a capital J, and that equals force times the change in time. The symbol J, which represents impulse, is expressed in Newton seconds. So this is the units at which impulse is measured in. So again, impulse is measured as Newton seconds. And how do we get that? Well, you'll notice that force is measured in newtons and time is measured in seconds. So we just took the two and put them together and we get Newton seconds. So that's the unit of measurement for impulse. Now, as we saw earlier, we said that impulse is equivalent to the object's change in momentum. And we can actually take this equation and actually break it down to its components. And so, breaking down J, we get force times the change in time. Breaking down change in momentum, that's m times the change in velocity, which when you look at this equation now, this is actually known as the impulse momentum theorem. And because of this theorem, we can make a direct connection between how a force acts on an object over time and the motion, the relative motion of the object. In this case, the velocity, the change in velocity of that object. Now, the reason why impulse is important and useful is that in the real world, forces are often not constant. Forces due to things like people and engines, they tend to build up from zero over time, and they may vary depending on many factors. And so the idea of working out the overall effect of all of these forces directly would be quite difficult. So instead, when we calculate the impulse, we instead would just simply take the force and multiply it by time. And this is equivalent to finding the area under a force-time curve. And so let me give you an example of that. So when we're talking about a force-time curve, I'm talking about a graph. And so this graph, which, when you're thinking about a graph, you have a y-axis, which is the vertical axis, and you have an x-axis, which is the horizontal axis, where y represents the force and x represents time. Because force varies over time, when you have a certain object that is experiencing it, you might get a slope or a curve that might look something like this. So you can see that over time there is a change in force. The force does change over time, and we get something like this. Now, by showing or illustrating a force time curve, this can be useful because essentially, if you think about it, the area underneath the curve represents the impulse itself. So in other words, if we were to find the area underneath this curve, we would have found the object's impulse over that given amount of time. And so this is a better way to sort of figure out all of the forces acting on an object over a certain period of time. This is a more generic overall way to put it all together. And so if you wanted to solve for the impulse, we would just simply need to solve for the area underneath this curve. Now, here's how that works. Well, you'll notice that force and time are two major components that will solve for impulse. and you'll notice that force is being multiplied by time. Well, you can see here that time represents the base, and force represents the height. And if you were to look at the equation for area, area equals base times height. Well, since the base represents the time and the height represents the force, and the two variables are multiplied by each other, then it makes sense to say that the area of the shaded area underneath the curve is actually related to the object's impulse. And so we can use this graph and simply find the area just by looking at this graph here and calculating the area underneath the slope. Now, what you would do is once you have, if you see this this whole shaded area, the first thing you would probably have to do is make sure that it's all divided into its individual shapes. I can see a right triangle here, and so if I wanted to find the area underneath this right triangle, all I have to do is find the area of the triangle, which is 1/2 base times height. So again, the area of a triangle is 1/2 base times height, or sometimes I like to put it as base times height divided by 2. That's the exact same thing, but it's easier to look at it when you write it like that in my mind. If you're looking for the area of the square, that's really simple. You just basically take the base times the height in this situation. So again, you would probably need to find the base from that point to that point, and the height from that point to that point. And then for this last shape here, again, you would probably need to find the base between these 2 points and the height between these 2 points, and then eventually use the equation base times height divided by 2 to solve for that area. Once you have found all 3 areas, then simply just add up all the areas together and you'll get the total area underneath the curve, which is basically the impulse of that object over that certain period of time.